Hey everyone, my name is Matt. I'll talk to you a little today about Dask. These are new slides for me today, so you guys are going to be with me trying some things out. Dask has been around for a while, and it is lovely and also has lots of challenges. I want to talk through some of those things. So first, very briefly, and talk about what Dask is, a little small demo, and we'll talk about those pros and cons. So Dask is a library for general purpose parallelism in Python. It is an open source library that is distributed by default with Anaconda. Probably you already have it installed on your computer. And it's also a bunch of other stuff built on top of Dask. So Dask is very much a toolkit that people have used to build a variety of different things. And you might be using Dask without knowing it. So at a very basic level, Dask is, the technical term for it is a dynamic task scheduler. That means that you give it a set of things that you want to run, and it decides where to run them on whatever hardware you've given it. You can give it a laptop and 1,000 functions you want to run, and it'll figure out how to run those 1,000 functions in a certain order on that laptop. You can give it a cluster of 10,000 machines, and it'll run hopefully that graph of functions a little bit faster. So we're going to see what Dask looks like at a low level, and then we're going to go up a little bit higher and see how we use Dask to parallelize libraries like pandas or Numpy or Scikit-Learn or PyTorch. But we're going to start low level at this fairly basic, just run a bunch of Python functions level. So let me switch a little bit briefly into a notebook. So I have here a little Jupyter notebook on the left, and you don't really need to look at the code too much. I want to actually focus you on the right side of the screen. So I want to show you these three panels in what is the Dask dashboard. And the center panel here is showing us some functions that I've asked Dask to compute for us. I've asked it to compute three functions, increment and double, onto some basic numbers. And I've asked it to add those two numbers together. And so we can see that representation here. Dask has taken my function calls and it's made a little graph of those calls and how they depend on each other. We also have over here a Dask cluster with a single worker, just this one little orange dot. So this is a very simple case. We've got three function calls, we've got one worker, and Dask ran those three function calls here. Looks like it ran these two functions in parallel, then it ran this one after it. So Dask is just a way to submit work to run on some other computer. It becomes more interesting when we run not three function calls, but a few hundred. So here I'm now asking Dask to compute 128 times. I'm asking it to compute these three function calls dependent on each other. It's a very simple computation, but there's more of it. And you can see our one little worker here is busy receiving tasks and doing work and turning on some work here. You can also see I'm saturating 4 threads on this one worker. So this one Dask worker has 4 threads. So it's running all of these functions in parallel. So you can see us making a little bit of progress up here as these tasks go from a waiting state to being in memory and then being released. Now that one worker is a little bit lonely. So over here, again, we're showing the hardware we have access to. That one worker is a little bit lonely. Let's give him some friends. We'll ask for 10 more workers, right? And so now there's a lot of workers doing some work, and you can see that things are happening a lot faster. You see the progress is being made down here much more quickly. And you can see that here now, rather than just 4 lines operating in parallel, we've got 40 lines. So we're able to do a lot of our work a lot faster. This is a very simple computation. It's worth noting that Dask can do more complex things. So here's some sort of a tree summation algorithm. And you see those workers are passing data between each other with these red lines, and they're doing that more complicated work now in parallel. And so again, I want to reiterate that Dask is a system which takes a computational graph like this, which is something we're asking to be done, and it also takes as input a bunch of hardware we have at our disposal, a bunch of computers that are running Dask for us. And it runs the graph on the left on the graph on the right and produces a nice result for us. And we can play with both of those graphs, right? I can delete some things in my notebook and the task graph goes empty. Maybe I'm done using all my workers. I can scale down just to 2 workers. I've got less resources to work with, but also less cost. And I can scale up, but I can do a more complicated, more dynamic computation as I like. And so I can really start to play a little bit with both computation and with scale in a fun way. And so Dask is a way for me to write Python code that operates at scale. And that's fun, right? Python isn't normally thought to be a sort of a big data language or parallel computing language. But technology like Dask turn it into one, which is quite fun. This is showing Dask at its sort of lowest level, which is a way to run Python functions in parallel across many machines. And that's a very useful level to use Dask. About half of Dask users just use that level. They're sort of replacing a for loop and trying to make it more parallel. But on top of Dask, many people have built a variety of other libraries. We actually built Dask originally with the goal of parallelizing some core libraries like pandas or Numpy, which are very, very common in the Python data science space. Many people use pandas and Numpy and Scikit-Learn and Jupyter and PyTorch, all these libraries on a single computer, and they really like that they're very flexible and that they're very easy to use. But these libraries don't scale very well. And so Dask, by working with these libraries, has been able to produce parallel versions of these libraries. So I'm now going to give a quick demo of that in this other notebook. It'll be very brief. So let's connect to a different Dask cluster. So again, I've got here, 6 workers that I'm playing with. I've got a little tiny data set here. It's a time series data set. Oops. And I can do, pandas-like operations. And what we'll see here is that Dask is turning my Python code here into a task graph like what we saw before. And it's executing that task graph in parallel. So you can see Dask is making some data. It's doing some group by operation. It's doing a little bit of a transfer in here. And Dask is doing all this work for us in parallel in a nice, pleasant way. So that on my left on the Jupyter Notebook, all I'm doing is writing pandas-like code, and Dask is splitting it up and running in parallel for me. So as another example, I might join this data set against some other repartition data set. And again, Dask has turned my pandas-like code into a task graph, a bunch of little Python functions that have to run in a certain order. And it executes those functions on my parallel hardware. And so I can just go and I can play as I would in a sort of a pandas-like context. I can train a lot of models in parallel, and Dask will do that work for me in parallel. And so again, I really want to give this impression that Dask is doing a few things here. It's taking high-level code, in this case, some Scikit-Learn pandas code. It's translating that into some small task graphs like these down here, which are sort of a recipe for the thing we want to build, the thing we want to run. And then it's also taking some hardware and it's running this graph on the left on the graph on the right. And we're seeing the trace of that up top. And so Dask is really a variety of different systems that all play well together in order to give a sort of native Python at scale experience on a broad variety of hardware for a broad variety of problems. So that's a brief demo. If you ever want to run demos like that yourself, you can go to examples.dask.org. There are a variety of examples here that you can play with. And you can also press this launch binder button and you'll be taken to an environment just like mine, where you can run these examples yourself. If I'm super boring, this is a way more exciting place to go and spend some time. So again, Dask takes humans, us at the top, and it's got computers down here at the bottom, and it tries to connect those humans with computers with dynamic task graphs. And on top of Dask, there have been libraries like Dask and Pandas and Dask and Numpy that have been written to provide kind of drop-in replacements for common workflows people use today. But people have also built a lot of other stuff on top of Dask. It's not just Numpy and Pandas. So there's a variety of machine learning libraries that are now Dask integrated. There's workflow managers like Prefect or Airflow or Dagster. And there's some people who just use just the low-level system to parallelize their own systems. If you go to dask.org and go to the bottom, you'll find dozens of different packages that are all built with Dask in mind. If you go to PyPI, the Python Package Index, you'll find hundreds, I think it's like 400, 500 different Dask-powered packages today. So Dask is kind of like computational infrastructure. It's something that other library developers use in order to scale up their workflows. You can use it in the sort of a generic, basic run a bunch of functions way, or you can use it in sort of these sort of big data ways that are also pretty common. And then Dask is very easy to run on your laptop, but it's also very easy to connect to a variety of different kinds of computational hardware. You can run Dask today on Kubernetes systems, on various cloud providers, on high-performance computing job schedulers, on old legacy Hadoop Spark systems, if running Yarn if you want to. Dask can really connect you to lots of other existing computational resources. So that's what Dask is. I now want to spend the rest of the talk talking about what I love about Dask and what I find challenging about Dask, what users find challenging about Dask, and how we're working to address some of that. So before we talk about what I love about Dask, kind of talk about what I love about Python, right? What I love about data science more broadly. In general, Python has succeeded, I think, because it lets us do the common use case really easily. You can just import pandas, load in a CSV file, do some quick analysis. And all of that really is easy to do. It's already kind of pre-canned for you, much like a database would make that very easy. But Python also lets you customize a little bit extra. It lets you add in your own special sauce, your own creativity into that problem. And it's that mix of being 80% ready to use, but giving you that extra 20% of flexibility that really makes Python an excellent language for innovation. So that 80% I really mean is all the libraries that we use, often in like the PyData ecosystem. And that 20% I mean raw Python code, I mean libraries like Numpy. We're writing a lot more custom logic. And again, it's that combination of the really common case with the ability to go outside the common case that makes Python beautiful. If you compare this to other systems like C++ or SQL, which take other extremes, it makes it a little bit more clear. So Python, again, has a sort of common case is really easy. You can also do some standard things. If you look at a system like SQL, the common case is trivial, right? You just write in your SQL query and you're done. But there's really no attention paid to customization. Right? People usually go to Python, they go to data science when SQL isn't enough. And they want a little bit more. Certainly a system like C++, it's all about custom systems, but there's not a whole lot given to you as standard. Python has that. All the standard stuff is there, but you can also branch out a little bit. This is kind of the same for Dask, right? Dask gives you the sort of standard interfaces for something like a big pandas. Maybe you want to replace Spark with a more Python-focused workflow. But it also lets you break out of just the big data frame. It gives you that low-level task interface to build more systems. And that's, again, why Dask, I think, is often preferred over systems like Hadoop or like Spark, which kind of lock you in a little bit more. Dask has a lot more flexibility, and it gives you a lot of space to play and a lot of space to innovate. It allows you to be more productive because you can be a little bit more creative. Point two, what I love about Dask, that it's part of an existing ecosystem. So often if you look at software projects, they'll show you sort of their ecosystem chart. They'll say, one way to do that is say, hey, look, I'm project foo, and here are all these other foo projects on top of me. I kind of did that in the beginning when I talked about Dask. Another way to talk about ecosystem is saying, hey, I'm foo, I'm in the middle of this whole thing. Here are all the other projects that relate to me and how I'm in the center of the universe. There's also a different approach, which is to say, here's the ecosystem, and here's the small part that I play in that ecosystem. And that's what Dask does. And it does this for the broader Python data science ecosystem. Dask doesn't try to reinvent the world. Instead, we've taken on very much of a service mentality for Python. We've tried to work with all of the existing libraries and tried to lift them up into scalability. This is where I think Dask gets actually a lot of its strength. I actually really like this cultural aspect of Dask. Again, Dask has more of a service mentality. We fix things in other projects, we spin things out, we try to provide value beyond our own software project. We're also very social as a result. It's worth pointing out that Dask is part of the NumFocus Foundation, which a variety of other libraries like pandas, like Numpy, and others are all part of. So we very much try to be in this group of projects that all tries to be very, very social and tries to be very, very service oriented. Point number three, Dask is really easy to get started. One of the best things I love about Dask is I can sit down with anybody. They can have some Python code, and we can get them using Dask in a few minutes. It's actually really, really easy to start. So again, you probably have Dask installed on your computer right now. It comes default with Anaconda. If not, you can install Dask, conda install Dask. And you might have some very simple code. Here's an example script. I've got some function which takes in a file name and processes it in some way. And I'm just running that function in a for loop over a variety of file names. If this function takes a while, if I got a lot of file names, I might want to use a variety of cores on my laptop. My laptop has got 12 cores. I could be going 12 times faster. And so it's very easy just to pick up Dask and throw in a few lines of code and run that. This requires no setup. You can just import Dask and start using it. Dask will, by default, it can run on a massive cluster of 10,000 machines, but you can also just run it inside of a local process, and it'll just start up a thread pool. And it'll just use something very gently in your existing system without requiring you to go through a whole lot of setup. And it just makes it very simple as a result. Dask is very lightweight. It's very easy to get started. And then as you start using this and you want to scale up, you can connect it to Kubernetes cluster, or if you've got an HPC machine lying around, you connect it to that, or you connect it to the Yarn, or you connect it to the cloud. And it's really this transition from from just Python to a bit of parallelism on one machine to parallelism on lots of machines. That's very, very pleasant. And that smooth transition is very, very nice for folks. So again, this is my sort of third love of Dask, how easy it is to get started. This transition is actually the most important. Once you do this, it's actually pretty easy to go to distributed. It's this transition which is the most fun, I think. Okay, so love number 4. It's actually been really fun working on Dask because of all the users. There are, I don't know, many thousands of people who use Dask today, and it's great to be able to serve all of them. They actually work in different industries, they work in different fields, they got different backgrounds. But there's a lot of them. As an example, so the Python Software Foundation survey runs Python Software Foundation runs a survey every year, and they ask Python users, what big data tools do you use? And Dask is about the 4th most common sort of parallel programming library in Python, behind libraries like Spark, Kafka, and Hadoop, which makes it actually the most popular one that's sort of Python focused. And we're about a factor of 2 behind a technology like Spark, which admittedly has greater adoption, but we're catching up. But what's lovely about this is we get lots of impact across lots of different spaces, in lots of different industries. So people often ask me, what is Dask used for? What's this killer application? The answer is it is used in time series analysis, in financial modeling, in climate modeling, in weather prediction. It's used in biomedical research. It's used in image analysis. It's used to analyze corruption data. It's used to analyze political contributions in different governments. It's used in government. It's used in nonprofits. It's used everywhere, and that actually makes it a really broad space to play in, and you get to have a lot of really broad impact. So if you want to have broad impact, I would encourage playing with Dask a little bit and seeing if you contribute a little bit. The impacts on this project have very broad, far-reaching consequences. To go through a few examples, actually, let's play a little bit with seeing some of those examples in practice. So we've seen things like me playing with the Jupyter Notebook. This is looking at CSV data sitting on Google Cloud and running pandas-like workflows over it. This is kind of the common case. 30–40% of Dask users are just doing big pandas. Another really common use case is the same thing, but not with tabular data, with multidimensional data. So this is showing changing ocean currents off the coast of Japan. It's still a challenge to run this code at scale, but it's a different kind of data set. It's not like pandas, it's like Numpy. Similarly, here's a 3-dimensional image viewer. This is called Napari. We're looking here at a 3-dimensional time series of a cell splitting. This is all Dask powered because these data sets get very, very large. This is a project called Data Shader, also Dask powered. And they're looking at GIS data, looking at geographical information data. And they're able to operate at great speed because Dask is able to do these computations in parallel. Dask also backs live web applications. So this is showing another streaming application showing cybersecurity data. So Dask is fully real time. Dask has also been built in a variety of different other libraries. This is Prefect, for example. So we're showing on the left the Prefect dashboard, on the right the Dask dashboard. And then finally, GPUs. There's a team of 50, 60, 70 people at NVIDIA, the GPU company, all using Dask to build more GPU accelerated data science technologies. So that gives you a very quick tour of some of the spaces in which we see Dask being used today. If some of those are interesting to you, you can go and take a look at YouTube and look at the Dask channel. There's a variety of interesting talks there from a variety of different applications. So moving on a little bit. So what do I hate about Dask and how are we fixing it? I was writing these slides and I didn't want to keep saying I hated Dask. That felt a little bit harsh, so I decided to talk about Dask challenges. I hope that you forgive me. So I'm talking about sort of the 5 things that I see most commonly when talking to users or to companies trying to adopt Dask, and also how we're trying to address that. Good time to mention there's a Dask company, Coiled, which I work for. A variety of the maintainers work at Coiled, and we're all now trying to work to push Dask a little bit further and have it have more impact, both for individuals and for institutions. So the first most common complaint with Dask is memory management. This is how we do more with less. So this really comes down to the common challenge people have is they have a 100 terabyte data set and they don't want to rent a 100 terabyte cluster because a 100 terabyte cluster is actually really expensive, right? It costs something like $1,000 an hour. But if you can process very large data sets in small space, you can be far more cost efficient with your analysis. Now, Dask is actually extremely clever about memory management. It is the most sophisticated memory management system that I think exists in a broad sense. However, it's not always clever enough. One of the challenges of Dask comes back to one of those loves. Dask is in so many different applications. It's actually quite difficult to handle all of them perfectly. If we were just a SQL database, if we were just doing tabular analysis, it'd be very easy to make Dask fully robust and fully efficient. But trying to handle all these different use cases is actually quite challenging to make one system to handle all of that. Dask does pretty well, but often it does fail. And so we're working very hard to improve memory management. This is, again, the most common source of failure, the most common source of excess costs. So the smarter you can be with memory management, usually the better the project is. Second is mature deployments. This is maybe the second most common pain point that we hear from users. It's really easy to get started with Dask. I showed you this slide earlier. I said, hey, look, you got your Python code, you annotate it a little bit, you throw in Kubernetes, and it's beautiful, right? And this honestly was a lie. This is easy to get going for proof of concept, but if you actually try running this in a more production setting, it tends not to work for a variety of reasons. You need to manage software environments, you need to manage security, you need to manage permissions, you need to get IT happy. And so this ends up being a little bit of a challenge. What we find is that usually it's sort of like a top data scientist or a top data engineer in a company. They adopt Dask, they have great success with it. They then try to roll that out to the rest of their team. And then suddenly that they start becoming more of a DevOps engineer. And this ends up distracting them a lot. They still often have great success. They transform the way their team does data science at scale, but it comes at a cost of them having to maintain a cluster for a while. Dask was sort of so easy to get started, we sort of accidentally tricked a bunch of data scientists to figuring out DevOps in order to get this capability. Putting on my for-profit hat a little bit, this is what we sell at Coiled. We sell a managed offering around Dask that makes it very easy to get a cluster of a variety of different configurations securely within your cloud. I apologize for the for-profit hat. So this is the second challenge, just deploying it in a more mature way that an institution can be comfortable with is what's often stopping more sort of institutional adoption. Challenge 3 is the sort of the shifting open source landscape. And what's beautiful about Python and R and all the other data science languages is the rich ecosystem of software libraries that we all work on together. There's hundreds of different teams all working, kind of collaborating, and it all kind of works out. However, that rapidly shifting landscape can also cause some concern when we're operating in a more locked down, a more conservative, a more slow-paced environment, which is often necessary in a more production setting. This often manifests in 2 forms. One, mismatched versions between Dask workers and clients. This is a very common error message that we see. That you've updated your software everywhere except in this one computer, and that's still running the old version of pandas, and that causes issues. It also often manifests in statements on GitHub saying, hey, I just tried upgrading X, but now Y is broken. For example, I just upgraded Arrow, but now Dask's Parquet IO support is slow in some ways. Not that that happens in this particular case, but things like that happen every week or two because there's so many updates to the ecosystem happening all the time. This is a challenge. It's actually a challenge that we need to figure out as a community. We're all kind of working on doing better upstream testing. We're all working on publishing things in a more locked down way. At Coiled, we're working on more of an LTS distribution, with sort of ecosystem level testing around Dask. That's at the Coiled Runtime Repository, which we started working on last week. Feel free to come by and help out. But this sort of ecosystem level testing is not something we've done well historically. I think is something that we do need to work on as technologies like Dask and like Python more broadly get adopted more and more into production environments. Fourth is kind of a silly one, but style. I made our Dask webpage like 7 years ago when we were first getting started, and no one should trust me with CSS. It looks better than, I don't know, not much. And so what's nice now is we actually have, we've got a lot of people using us, people are willing to donate designer time, we've got money, we can hire our own designers. And so we're playing a little bit with restyling. If you care about Dask, you want to get engaged into more of an aesthetic conversation around Dask or how we message ourselves, there's a GitHub issue that you can engage on to voice your thoughts. It's nice having someone who's not me be in charge of design. And then finally, I'll say is sort of the biggest challenge thing to Dask right now is institutional adoption. Humans have decided to adopt Dask, but corporations have a different decision mechanism. So I mentioned early on that Dask has decent adoption among Python users. If you're at a company with about 20 Python users, chances one of them uses Dask. But if you talk to the sort of the CTO of the company, if you go up to sort of the board level of a company, Dask really isn't present. Dask is not commonly used, not commonly thought of as being something that a company adopts. It's much more on the sort of individual level. This is for a variety of reasons, right? Dask hasn't marketed itself to companies. We haven't really been a business until very recently. We also don't have things like enterprise support, SLAs, identification, SOC 2 compliance, et cetera. We do now with Coiled. Coiled provides all of those things. But for a long time, Dask was just focused on individuals and on really having impact at the individual contributor level. And we weren't really focused on transforming institutions. And now there's a bit more of a shift towards that. So that's it. I'm going to stop. So in summary, Dask is a really powerful tool. Hopefully some of the examples I showed you give you that sense. But today it's limited by, I think, an overly diverse application space. We do so many different things. It's actually challenging to support all of them at the same time. We've also been limited by, I think, a focus on individuals rather than institutional users. We've kind of got the Python users. Python users like using Dask. If you go to a PyCon or PyData or SciPy conference, you'll find that Dask is by far the most commonly talked about tool. There's more talks about Dask. It's a de facto standard for scalable computing in Python. But we really haven't served the more institutional users, and we need to sort of level up in order to have greater impact. If this kind of thing interests you, we're trying to solve this problem at Coiled. Again, Coiled is a Dask company. Come and check us out. So that's it. I will try to figure out the GoToMeeting system here and see if I can help answer some questions. So Terry asks, are there sample notebooks that demonstrate different Dask use cases? Yes, Terry, there are example notebooks. I'm so glad you asked. They're at examples.dask.org. And there are a variety of different examples here, go through a variety of different use cases. And let's say we want to analyze web-hosted JSON data. There's a nice little render notebook that we can go through here and see how things look. We can also, at the very top of any of these pages, you can click this Launch Binder button. And in about a minute, you'll actually be dropped into a Jupyter notebook that's running Dask on one instance in the cloud. And so you can play with things on your own. So this is a great way to get started with Dask. that takes really no effort at all. It's more fun to do this than to listen to me.